Hello, everyone, and thank you for joining today's webinar, the second in a four-part CALGreen Embodied Carbon series, Whole Building Lifecycle Assessment for Code Compliance, made in partnership with the CEOC Sustainable Design Committee. As you get settled, please feel free to say hello and where you're joining from today in the chat. To qualify for continuing education credit, AIA California provides the learning objectives for every webinar and includes them in the PDF presentation that can be made available online. We will provide links in the chat box where you can find upcoming and on-demand climate action and VNCD webinars from AIA California. A few housekeeping reminders. Today's session is being recorded and can be made available on the AIA California website. Today's session qualifies for one AIA HSW learning unit and 1 hour of VNCD mandatory continuing education. For those who stay on and watch live, AIA California staff will report these units for you and will send you a VNCD certificate of completion in the coming days. Please use the Q&A function to ask any questions for today's presenters. You can also like a question to move it to the top of the queue. Finally, cultivate a positive learning environment. AIA California strongly encourages attendees to be constructive in their comments and questions to the presenters and to each other to foster a positive learning experience for everyone. I'd now like to introduce our co-moderators for this CALGreen Embodied Carbon series. Luke Lombardi is the Senior Sustainability Consultant at Burrow Happold. He chairs the CEOC Sustainability Design Committee and is a co-lead of the CLF LA Hub. And Avide Hagigi is an Associate Principal and Licensed Architect at VGF and founder of Zero House. Avide currently serves as the chair of AIA California's Embodied Carbon Working Group. Thank you guys both so much for being here today, and I will hand it off over to you.
Thanks so much, Sarah. Great to be here talking about CALGreen and embodied carbon again. And thank you to everyone who's taken the time out of their day to be here. We're also lucky to be joined by Laura Carnath, Senior Consultant at Walter P. Moore and co-leader of the CLF LA Hub, as well as Isabel Hins, Environmental Designer at A10. Both will be sharing their perspectives with project examples and information about resource groups forming to support whole building lifecycle assessments. And to make this more of a party, we'll have some support in the chat from a few friends. You'll recognize Anish and Amy from webinar number 1, and they're joined by CEOC Sustainable Design Committee Chairs Rochelle Habshi and John O'Hagan. You can tell a lot of people have come together to make these webinars happen. This is part 2 of our 4-part series. There will be an additional 2 webinars going into greater detail for the remaining compliance pathways. So be on the lookout for more information from AIA in California and CEOC about those programs. As a reminder from last session, this code will be going into effect starting July of this year for non-residential buildings over 100,000 square feet and schools over 50,000 square feet. There are 3 possible compliance pathways. There were a lot of questions last time about what is included and what projects are excluded from this requirement. So here's a snapshot summary. The recording and slides with much more information and context are hosted on the event page and will be shared once again in the chat. Today's program is all about whole building lifecycle assessment. Structural engineers and architects play a pivotal role in implementing CALGreen requirements effectively and shaping the future of sustainable construction. We will be exploring best practices and practical considerations for practitioners, as well as tools and resources to ensure compliance. There is a lot we could talk about with LCA. The focus of this presentation will be to provide an overview of the topics needed to meet compliance specific for CALGreen. We are cognizant that it is a lot to take in for people new to the topic, but this slide deck and associated resources will be made available so you can access them later. Additionally, there are groups where you can find support and help on the topic. We recommend following up and engaging with your local Carbon Leadership Forum hubs, as well as AAA and CEOC committees. In developing this presentation, it was clear that additional supportive webinars will be required, and given the time constraints today, we will not be covering some of the high-level Embodied Carbon 101 or other background climate science information that is more readily available from other resources. We will be working through a simple example and going through the CALGreen reporting compliance template. A link to this template will be shared with the resources at the end of the presentation. And it's important to note that this template will be required as part of the permit package and submitted as part of your drawings and/or specifications, just like it is for energy modeling compliance. This is important to keep in mind with the timing as we walk through the LCA process here. And there's a tremendous amount of helpful people and resources in the embodied carbon space. Before we dive in, we just want to take a moment to thank everyone who's contributed or published resources that supported the development of this presentation, as well as the many individuals who reviewed it.
Thank you, Luke. So we're going to go through some basic terminology. We'll start there. What I like to call the terminology soup, so that we're all clear on what these terms mean as we're referencing it throughout this webinar. So an LCA is abbreviation for life cycle assessment. WBLCA is a whole building life cycle assessment. So a whole building life cycle assessment takes into account the entire building and its entire environmental impact. And we're going to go into more detail on what that means. An EPD is an environmental product declaration. It's basically like a nutrition label for building materials, and it discloses the environmental footprint associated with that specific building material. EPD basically measures the greenhouse gas emissions related to the manufacturing of that material. So that's abbreviated as GHG. It results and it discloses a GWP potential, so global warming potential. And the main unit for reporting global warming potential is kilograms of carbon dioxide. So it's kilograms CO2. You'll see this unit over and over again in this presentation. And if you see CO2e or CO2eq, that's equivalent. Because in the manufacturing of products, there's lots of different types of gases and emissions that may get released, and they all have different units. So it's industry standard to convert everything to carbon dioxide equivalency as the one metric of reporting. One thing I'd like to clarify, as I've seen a lot of confusion between these two terms, an LCCA and an LCA. An LCCA is a life cycle cost assessment. It is evaluating the cost implications of certain systems and the maintenance, the cost associated with the maintenance of those systems. And LCA is evaluating the environmental impacts of buildings and building products. And LCA, in fact, has nothing to do with cost. Cost is not taken into account at all. So these are two completely different studies. They're done using completely different softwares and methodologies. And you may have heard the term embodied carbon, obviously, at this point. When we say embodied carbon, we really mean global warming potential. So those terms are going to be used interchangeably. Now onto my favorite part, some myth busting of things we've been hearing. So you may be thinking, oh God, an LCA is going to cost too much. We can't really afford it on our project. Well, we'd like to share with you that an LCA typically costs a small fraction of project fees, as typically less than 1% of the project fee, not even the construction cost, but of the project fee. And you may also be thinking you may need to have some specialized expertise to run an LCA. That is not true. Anybody can learn to do an LCA with a basic understanding. And I really hope that by the end of this webinar, you agree with that statement. And you may also be thinking that maybe you need to pay for a certified consultant to run this study. While you can choose to do so, we do want to make it clear that LCA does not require any professional accreditation. So there's no special accreditation somebody has to get or have in order to run an LCA. Also, another common myth is that an LCA takes too long to run, is too complicated. Oh God, how are we going to do this? So here to ease your concerns with that, a typical LCA takes on the order of 40 to 80 hours to run. Now, obviously, that is dependent on the project complexity and how clean your Revit model is. So there's definitely ways to simplify the process so that the LCA can be run faster. Also, for the structural engineers in the audience, you may be wondering how this is all relevant to you. You've never had to worry about CALGreen. Now, all of a sudden, we're talking to you about CALGreen. So, in fact, actually, for embodied carbon, as many of you know now, structural engineering is going to be a very integral piece of reaching the embodied carbon mandatory measures now. So when we say whole building life cycle assessment, it's the assessment of all these phases of a building and material life cycle. So it includes the extraction of raw materials, the manufacturing of the material, the construction of the building, and the installation and use of those materials in the building and the building itself, and the end of life. So what happens at the end of life of that building and those materials, and can they potentially be reused or recycled? So a whole building life cycle includes all of these stages. Now, the concept of whole building life cycle analysis is actually very simple. We're here to simplify things for you. So essentially, you have a quantity of a material. In this case, let's say it's 100 tons of steel. Then you have an associated global warming potential for each material. So in this case, let's say it's 1,000 kilogram CO2s per ton of steel. So if you multiply the 100 tons of steel by the 1,000 kilogram CO2s, you end up with 100,000 kilogram CO2s that represents the overall environmental impact of this specific steel and this amount of steel on your building. Now, if the amount changes and the material changes, of course, these numbers will change. But essentially, in a whole building LCA, all you're doing is you're gathering the quantities of all the materials in your building. You're getting the GWPs, which come from EPDs, as I mentioned earlier, and you're doing the calculation and tallying it all up.
All right, we're going to dive into some of the details of that now. LCA can be broken down into 4 basic steps. The goal and scope of the analysis define the rules. An inventory is then completed for the building materials by type and quantity for the elements that are defined in the scope set in step 1. Then the impacts of each material are itemized for that inventory, and results, which should be studied for errors along with the conclusions that you're looking for, documented toward the goal defined in step 1 as well. First and foremost, important for any comparative LCA, we need to maintain consistency. The goal and scope of every CALGreen compliant project will be the same. We're going to be studying a building over the lifetime of 60 years with a goal of 10% carbon reduction. What is included in this study is known as the system boundary and is comprised of 3 aspects: physical scope, LCA scope, and impact categories. The impacts considered in CALGreen is we're only looking at carbon. So while there may be numerous aspects of sustainability that are important, this code focuses only on the climate change causing carbon emissions. All other impact categories, like those that you may have heard from LEED, are out of scope. LCA scope refers to the stages of a product's life. We have a framework of terminology to communicate this scope consistently. Scope A1 through A3 characterizes the manufacturing of a product. You may have heard this referred to as cradle to gate. Transportation to site and construction on site are known as A4 and A5 respectively. Scope B defines the use of a building over its lifetime, and Scope C defines what happens at the end of life. CALGreen requires whole life carbon, so the carbon emissions of each stage of life be included in accounting. Assumptions on available data are incorporated by the LCA tool. However, some tools may only have data for cradle to gate emissions and do not have data for the remaining stages. This limits which tools are code compliant. Stage D occurs outside the scope of the building, such as recycling or reuse. This is typically reported separately and not part of CALGreen's requirement. The majority of these emissions typically come from cradle to gate manufacturing, which makes a lot of sense because this is where the most energy intensive, carbon intensive processes occur, often out of sight and out of mind. The physical scope is what is physically included or excluded from your model. CALGreen is modeled off of LEED requirements, which includes structure and enclosure, making collaboration between architects and structural engineers so important. Other elements of a building, such as mechanical systems or interiors, are optional but not required. The term whole building lifecycle assessment is a little bit deceiving in this regard because it refers to LCA scope, not the physical scope. A full list of Omni-class elements will be provided in the CALGreen guidance on AIA's website. One example of where we draw the line could be with the facade. CALGreen defines the interior skin, i.e. the gypboard, as part of the facade to be included, whereas you wouldn't have to include something like the paint, which is part of the interiors, the finishes. Here's just a summary overview of the full system boundary.
So we can now use the concepts reviewed previously to fill out that first section of the worksheet and also orient ourselves in the second section of the worksheet. So we can fill out that reference study period of 60 years and also the physical scope where the structure and the enclosure are required, and experienced LCA practitioners might include the other scopes as well. In the second section below, we see that LCA scope A1 through A3 all the way through C4, and then those impacts expressed in GWP in kilograms of CO2 equivalent. The remaining inputs in that first section are mostly straightforward and specific to your project. The worksheet does ask if biogenic carbon is included in your analysis, to which the answer will usually be no. According to the code, biogenic carbon storage associated with wood products shall be excluded or reported separately from your embodied carbon reductions. And biogenic carbon is a deep topic that we don't have time to cover today. So practitioners should make sure to research and understand this topic before including biogenic carbon in their analysis. And then that model floor area is the gross floor area consistent with the architectural drawings.
All right, unlike the goal and scope, the building inventory and impact factors will be unique for each project. Building quantities come from a number of sources, such as drawing takeoffs or contractor provided quantities, but most commonly today, this information will be captured in your BIM model. Because our Revit models only capture what's drawn, it's often important to supplement these quantities with some calculations for products like rebar that aren't modeled. Now, you don't have to count every bolt and drive yourself crazy. There is a threshold proposed by ASHRAE 240P, which defines any building element contributing more than 1% cost or mass to the building, or structural elements representing more than 5% of the structural system be included. It is critical to vet your quantities and ensure accuracy. Mistakes are common and often happen at assemblies like composite decks or foundations that are modeled as masses. Make sure your results are consistent with your judgment. Otherwise, you can end up with some very different results for something like a 3-inch metal deck here.
So here's what those material takeoffs might look like. Distinction should be made between different materials. So for example, a 5,000 PSI concrete in the foundation versus a 4,000 PSI concrete in the slabs, because those different materials will also have different GWPs. And then for this webinar, we'll work with these simplified numbers and just pretend like that is the whole material takeoff so that we can work through the example together.
So once we have our quantities, what is the actual impact of these materials? Impacts from manufacturing are defined in EPDs. EPDs are like nutrition labels. The functional unit is like a serving size, and the global warming potential like the calories for that product. EPDs only cover cradle-to-gate emissions. The remaining stages use other background data sets to fill in the rest. For example, a whole building LCA tool will attribute an assumed travel distance for a given product based on government data. It would also assume a rate of replacement, which for the structure is generally the life of the building, but for something like facade elements could be more like 20 or 30 years. Those emissions would occur during the B stage, the use phase, and occur over the 60-year life of the building. There are two types of EPDs. Industry average EPDs are developed by industry organizations like NRMCA or AISC, who collect data from their constituents and share the average impact. Product-specific EPDs are published by individual manufacturers for their product. This is like if you had a class of students who take a test, the industry average would be the class average, and product-specific EPDs would be like the individual test scores. Industry EPDs are applied to your baseline analysis, whereas product-specific EPDs can be useful in proving a reduction from the average. This is an example of a regional average published by NRMCA. It's noteworthy that NRMCA is going to be coming out with some new averages this year that are more geographically granular. But for this example, you can see 2022 report, there were 51 plants that were included in the data set, and you can see the averages provided based on strength. So one example here would be 349 kilograms per cubic yard for 8 KSI concretes. You can find product-specific EPDs in some LCA tools. This takes into account the variation in individual mixes and can be very important in proving carbon reductions from what's typical. Here's a quick study from EC3 of available EPDs around the Bay Area filtered by 8 KSI concrete. We can compare this to the NRMCA regional average and select a single EPD. For this mix in particular, we can see 322 kilograms per cubic yard reported in that EPD nutrition label.
So going back to the example, each of the distinct materials with its own material quantity also has its own GWP intensity. And the intensities shown here are just for modules A1 through A3 from the 2023 CLF baseline, which we will link at the end of the presentation. These GWP intensities can be found in EPDs or in your LCA tool, and this gives us all the information that we need to get to our final results. So to obtain the GWP, we then multiply the quantity by the GWP intensity and do the appropriate unit conversions. So for example, the concrete quantity was in cubic yards. The concrete GWP intensity is expressed in kilograms of CO2 equivalent per cubic meter. And so to get a value in kilograms of CO2 equivalent, that first quantity needs to be converted to cubic meters. So always make sure that you're using the right units throughout. And in general, this calculation will happen inside of the LCA tool. We just wanted to run through an example so that you make sure that you understand what happens inside the tool and what the mechanisms are. And then we can add up all the GWP values for the structure to obtain the baseline structure GWP, and the same for the enclosure. And then we can enter those values in the sheet and add them up to obtain that baseline whole building GWP. The values we calculated in this example, as I mentioned, were just for modules A1 through A3. So your LCA tool will output values for all of those stages.
While the simple calculation is useful when teaching the basics of LCA, it is important to mention that there are other factors in the analysis. This could include transportation mode or distance and means of transportation to site, as well as on-site waste factors. Although in the majority of cases, default assumptions may be appropriate, is not always the case. As more accurate information is known about the project analysis should be updated. In some cases, such as transportation of mass timber, this can actually have a significant impact on your results. We had a project in the last couple of years where the facade had to be flown in rather than taken by rail, and it nearly blew the carbon budget out of the water. So always be on the lookout for those one-off cases or things that intuitively you think might be high emissions. And it's also can be good practice to test the sensitivity of your results if there's a known uncertainty on the project.
Okay, so now that we've covered how to run an LCA and some of the basics there, you may be wondering, okay, great, how do I achieve the 10% reduction? So we broke it down into 4 simple steps. One is setting a baseline. So when we're talking about 10% reduction, the important question is reduction from what, right? So there needs to be a baseline that is set that I'm going to talk a little bit more in detail about. Then you evaluate reduction measures throughout the design process, different ways to reduce embodied carbon through different materials. Then you run your proposed LCA to see how your proposed design compares with the baseline design. And this is a check to see, are we getting the 10% reduction? Are we there yet or not? Oftentimes, and don't be surprised if you don't get the 10% reduction on the first try, oftentimes there needs to be a combination of reduction measures applied in order to get to 10%. And of course, repeating, this is a reiterative process. I like to compare it to the energy modeling process that many of us are familiar with now. You know, you don't wait till the end of the project to run the energy model and just cross your fingers, you're going to meet Title 24. No, you start working with your MEP engineer earlier on to make sure that you're on track to hit those goals. So very similar here. Now, in terms of setting the baseline, let's talk about that a little bit. Unfortunately, there's no industry standard yet for setting a baseline for embodied carbon analysis. CALGreen does give some guidance, and it's called a functional equivalency. That's just a fancy term for saying that the baseline building should be comparable to your building in terms of what a conventional building would look like, right? So the question to ask is, if I were to design and build this building, business as usual, what kind of structure would the building have? What kind of materials would it have? What type of construction would it be? So for example, if it's an office building, it might be a steel structure typically. So that's really important. And also keep in mind the size of the building must be the same. The size and program must be the same as what you're designing. And the GWP factors also for your baseline come from the industry average EPDs, as Luke mentioned. So when you're setting your baseline building, you're just assuming a conventional building built business as usual with some industry average products, right? Nothing too crazy, nothing too bad, nothing too good. So that's the baseline.
I might add one thing on this one, which is on that list of comparable things, it says material specification. And one distinction that's been made in the CALGreen compliance is that you can still compare buildings of different materials. So you could compare like a steel building to a alternative mass timber building. Just one kind of note that people could get hung up on there.
Only if the steel building, though, is how it would be conventionally built.
Exactly.
So then you move into evaluating reduction measures. As you can see on this graph, the sooner you evaluate reduction measures for embodied carbon, the more impact those moves will have, right? So the more opportunity you have for reducing embodied carbon. So we recommend starting even in conceptual design and schematic design. When you're making those big decisions of what the structure is, you know, those can have really big impacts. Those are not things you can change easily down the road again. So as the project moves forward, the opportunities for reduction get smaller and smaller, although you do still have an opportunity to get reductions even in the procurement and construction stage. So you first look for reductions in design, then when you go into construction, there's some opportunities there as well that we'll cover. So, and we want to make sure that the reductions are measurable and documented, right? It's really impossible to claim reductions if it's not documented anywhere. So for example, embodied carbon limits for specific materials should be listed out in your specs or in the project drawings or even in your materials sheets. They should be documented. So for example, getting EPDs from the contractor on what is actually installed. Those are ways to measure and document and show that, yes, we did actually use better products from conventional standard products, for example. And so once you have your baseline model, now here's the fun part where we can do a hotspot analysis. There's millions of products in any building. It's impossible to optimize every single product, right? So the smartest thing to do is to look for areas where there could be the biggest impact. So what are the biggest contributors to emissions in this specific building is the question you want to be asking. And you can look at this a couple of different ways. You can break it down by building components. So for example, looking at floors versus walls. And oftentimes floors will have more embodied carbon than walls simply because, you know, we tend to use lots of concrete or carbon intensive materials in floors. So if that's the case, then you can say, okay, we're just going to focus on optimizing our floors and getting the 10% reduction just by that. Then you can go down that path. Or you could evaluate it based on the materials on your building, like you see on the screen here. So what I will say is that in this case, you want to focus on the largest quantity of materials because the whole building LCA at the end is a weighted average calculation. So the largest quantity of materials, if you can focus on reducing the carbon impact of those, that will have the biggest impact on your whole building LCA reductions. In this case, you can see that the biggest impact is the steel beams, the lightweight concrete deck specifically, and the aluminum in the storefront or curtain wall panels. So then you can say, okay, we're going to focus on optimizing these 3 items. So some examples of good practice versus bad practice. Good practice would be, for example, the structural engineer and the architect working closely together at the beginning of the project, schematic design, when you're choosing the structural systems to identify which type of structural system is the best, but also maybe even drilling a little bit farther on optimizing bay sizing. This could be a huge lever that you can only pull in schematic design, for example. So optimizing bay sizes not only allows for optimal program functionality, but also could reduce embodied carbon, could be a strategy to get to 10% reduction. So that's always a good practice. And you always want to be comparing, you know, different types of structural systems early on. Now, bad practice would be, going back to the baseline discussion, setting a baseline for a system, a structural system that would never be used on this project. So for example, multifamily buildings in LA, typically the floor is a PT slab. Now it would be bad practice to set your baseline as a conventional slab, conventionally reinforced slab, right? That wouldn't be an appropriate baseline to set. I also, unfortunately, hear this from a lot of contractors like, hey, do we really need to worry about this 10% reduction? We could just set a really bad baseline. That way you can get 10% reduction super easy. That's bad practice. That's not recommended. It should be a baseline that is what would actually be built. And another opportunity for reduction is the concrete mixes. So concrete, and specifically the cement in concrete, is very carbon intensive, super carbon intensive. And no matter what kind of structural system is in the building, most buildings will have concrete footings, right? So there's still substantial amount of concrete in the building, and the concrete footings is actually a great place to start optimizing and reducing the amount of cement in the concrete mixes. Now, we could have a whole webinar about this, honestly. This is a very intricate process, and there are multiple things that need to be done to ensure that right mix is actually poured at the end of the day on the project, right? As you all know, many things can change throughout a project. So getting some embodied carbon or GWP limits into the specs for the concrete mixes specifically, and working closely with the contractor and the concrete supplier, if you know who that is early on, is a really great strategy to pick an appropriate target for your mixes. And then you want to make sure that that's actually getting installed by getting the EPDs. Now, a bad practice would be if you just go on AC3 and you pick the lowest carbon EPD for that concrete mix, and you say, okay, this is what we're going to go for, without checking with the GC or the concrete supplier on whether that's even available. Because concrete is obviously very regionally specific. And it's highly dependent on which supplier you're working with and whether they have the capabilities and the infrastructure to make low carbon concrete. So you always want to be working very closely to set a realistic target and then follow that through collaboratively. So a summary of different reduction measures available in the design phase and the procurement phase, as we've been covering. This is certainly not an exhaustive list. But, you know, as I said, in the design process, optimizing the structural system, the base sizes, optimizing the concrete mixes, reducing skin to floor area ratio could be a really great strategy because as Luke mentioned, envelope is included in the scope of the whole building LCA for CALGreen. One way to optimize that, for example, would be to optimize the facade support structure. Then, and when you go into procurement and construction, there's different opportunities. So specifying, for example, specific GWP limits and requiring EPDs to be provided by the contractor, type 3 EPDs specifically, and engaging the ready mix concrete suppliers to make sure you're getting the best mixes. So a quick note on the weighted average calculation for whole building LCA. So for example, if 50% of the building is concrete and you determine by talking to the contractor, engineer, everybody on the team that, okay, we can get a 20% reduction in embodied carbon for the concrete mixes, which is great, it's fantastic. That means that when you run the whole building LCA, you may only get about a 10% reduction for the whole building because that analysis takes into account not just the concrete, but all the other structural components and building enclosure components. So just keep that in mind. This is an example of how you can use iterative measures throughout different phases from design to procurement to achieve an overall 19% reduction in embodied carbon for the final proposed design, which clearly meets the CALGreen minimum of 10% reduction. So you may have to use multiple different strategies to get there.
Yeah, and then an example of a project that has successfully achieved at least a 10% reduction in embodied carbon is Emery Yards Building 2 in Emeryville. So this lab and office building by Flat Architects implemented a combination of concrete embodied carbon reduction, insulation procurement, and then rebar procurement to get a total reduction of 14%. And then this is a simplified example of what the completed second portion of that worksheet might look like for a project like this.
Oops, sorry, I was on mute. And of course, this process should be repeated, right? It's reiterative. Think about how you do reiterative energy modeling throughout a project. You can do reiterative embodied carbon analysis. Now, it doesn't have to be a whole building LCA. I'm not saying you run, 4 whole building LCAs throughout the project. What we're saying is that you can look at, do comparative studies of specific elements like structural base sizes or different types of insulation and see how much reductions you can get in those individual components throughout the project so that in the end, you can add it all up and get to the 10% reduction. Okay, my favorite part again, some myths. I've heard this from architects typically that okay, great. I'll just go ahead and source all the materials locally, and certainly that will hit the 10% reduction because, thinking about all the emissions from transportation. While I definitely want to encourage everybody to use locally sourced materials, sometimes that's not enough. A lot of times, transportation is the least impactful category in an EPD. Now, I want to clarify this. We're not saying that transportation doesn't have any impact. It's just that the impact from A1 to A3, which is extraction of raw materials and manufacturing, is just so much bigger than the impact from transportation. So oftentimes transportation impacts get dwarfed by the A1 to A3. So just keep that in mind. But as Luke mentioned earlier, there are cases where transportation may make a big difference. So evaluate this carefully. And some of you may also be wondering, okay, I can just design my project and just, trying to like optimize resources and be really efficient. So we're just going to do the LCA at the end of the project. This is definitely not recommended. It's pretty risky because there is a chance, very good chance, you're going to get to the end of the project, run the LCA and not meet the 10% reduction. And at that point, there is minimal things you can do, right? So, I mean, I don't know. You might get lucky, but not recommended. And of course, the last case, I think we've covered that pretty well now. In terms of artificially choosing a worst case scenario baseline, that's not recommended. Please follow the CALGreen guidelines for a comparable building, and that is considered conventional for that project type and that location.
Thank you, Avide. Thank you, Isabel. We're going to take just a couple minutes here to talk about demonstrating compliance. And we're going to bring this graphic back. It's important to pick the right tool at each stage of your analysis. And at this point, there are a lot of tools out there. Some tools like Epic or Kaleidoscope can be really helpful early in design to understand the overall impact of your project and assess design decisions that are important. Where others like EC3 have an extensive EPD library and are great for tracking material procurement later in construction. However, only tools that include the data from scopes B and C that we were looking at earlier meet compliance requirements of CALGreen. And as previously stated, this form needs to be included in your permit set in the drawings and/or Division 1 specifications. And just to reinforce some of Avide's points there, it really is important that you be doing iterative modeling through to the design stages. There's significant risk of waiting to do LCA until CDs or into construction because the influence of design and procurement are significantly diminished. And if you can't meet the whole building LCA pathway, we're limited in other compliance pathways like the prescriptive path at that point, where it applies to more products to have a GWP limit. You probably have perhaps a less environmental impact, and there's greater risk to cost or schedule than if you would have coordinated these considerations up front with the contracting team. The landscape of the tools that are available continues to change, and new tools become available or tools get built out further. Currently, there are 3 major tools that meet compliance that people use. It's OneClick, Tally, and Athena. These tools have varying pros and cons, as well as underlying assumptions and background data sets. Generally, you should not compare results across different tools. And we're not recommending any specific tool here, but we do recommend that you discuss functionality with other practitioners when considering what tool best fits your workflows. And as I said, there may be other tools that are useful. This is a non-exhaustive list, but just highlighting here the tools that are compliant for CALGreen. Some tools that are compliant for CALGreen but not as commonly used are Gabi and CIMA-Pro. Those are meet the ISO requirements for CALGreen, but are typically, they're less typical for buildings. They're more typical for developing things like EPDs. And we certainly will be talking a lot more about this and perhaps have our own webinar just about tool usage.
Luke, just chiming in real quick on the tools. I know there was a question for those people who are using AutoCAD, for example, or SketchUp. There was a question, do I need to be using Revit? No, you don't need to use Revit, but as you can see, it does make it a little bit easier because there's plugins for Revit. If you're in some other program, you may have to export the material quantities or get takeoffs from the contractor in order to run the analysis.
Yep, the only tool that requires Revit is Tally. That's just, it's functional within Revit. Thanks for calling that out. And we've made it now. Here we have our completed compliance form. And thank you, everyone. We have one more section here. I'm going to bring up Laura to talk about resources and working groups. Thanks, Laura.
So we've covered a lot in this webinar that we can't cover everything all in one webinar. So we're sharing some resources on embodied carbon and LCA for all of you. There are a lot of great resources out there. These are just a few, and the links for them will be posted in the chat. So first of all, we have a link to the code. Make sure you check out what the code language says. There are also some good guidance documents out there. If you're just getting started on your embodied carbon journey, the AIA and the Carbon Leadership Forum have worked together to publish a 3-part embodied carbon toolkit for architects. And a lot of the resources we have up here are from the Carbon Leadership Forum. They're an organization dedicated to reducing embodied carbon in buildings and materials. That's what they do. They produce research and resources related to embodied carbon, and it's a great first stop if you want to learn more about embodied carbon and LCA. And the CLF also has local hubs in a lot of cities where professionals from across the AEC industry gather to share knowledge. When you're ready to dive into LCA, the CLF has also published an LCA practice guide. It was also mentioned briefly earlier in this presentation that they have published material baselines. So the CLF material baseline report collects industry average embodied carbon data for a bunch of different materials and gathers it together all in one place. So it's really useful. For structural engineers, SE 2050 and iStructD have published guidance and strategies to help structural engineers calculate and reduce embodied carbon. There are a lot more here. We're also sharing some additional embodied carbon intro resources and some resources related to specific materials. And I know biogenic carbon doesn't have to be included in the CALGreen LCA, but if you're interested in a deep dive on wood and biogenic carbon, the CLF has also put together a webinar series that's recorded and up online called the Wood Carbon Seminars. There are also some resources that are currently under development, so there will be some additional guidance for the CALGreen embodied carbon measures. Stay tuned for that. Currently up for public review is ASHRAE 240P quantification of life cycle greenhouse gas emissions. So that's another standard that's currently under development. And SEI is also working on a pre-standard for assessing the embodied carbon of structural systems. So there's a ton of good stuff out there. If you're just getting started, start with those first couple of links that we shared. Next slide. So in addition, as you learn to do LCA and use LCA softwares, there are some resources available to help. There are 2 existing LCA user groups where people gather to share knowledge around LCA. There's currently one in Seattle that's hosted by the local Carbon Leadership Forum hub there. And there's one in Boston hosted by Built Environment Plus. The Carbon Leadership Forum Los Angeles hub, which Luke and I are co-leaders of, will be launching an LCA user group really soon. So if you'd like to be part of that and be notified when it launches, I think we're going to share a link to sign up in the chat for the CLF LA newsletter so that you can get notified when we get that up and running. So before I turn it over to Luke to wrap it up, I just want to really encourage everyone to use this as an opportunity to connect and to share knowledge and really make a difference on our projects.
Thanks, Laura. And just to close here and bring it back to why we're doing this. I think you've all probably seen figures like this relating to climate change with some sharp decline in emissions this decade. And while it can feel overwhelming, it's crucial that we recognize our agency as a collective industry to make an impact. This moment calls for broad-reaching policies and the actions of individuals like yourself to act and implement necessary change. It doesn't happen by magic, and it doesn't happen by doomerism any more than blind hope. And I really think CALGreen is indicative of the future we know must come to be. It's progress, and it's not perfection, certainly, but it is a framework to build on for our future. And it's validation that architects and engineers have a really important role to play in this transition, and a shift in focus from arguing why we should design better buildings to how we can achieve more ambitious goals. So engaging and encouraging discourse on this topic is certainly a step in the right pathway, and just very grateful to everyone taking the time here today to change our industry for the better. So with that, we have a few moments now for Q&A, and Rochelle is going to help us navigate all of the questions.
Okay, thank you. That was a lot of really great information. Okay, so there was a lot of questions about the baseline building. So I'm gonna focus on that first. So is the same building modeled with conventional means or another building you can find that is the same size? And would it be reasonable to set the 75% SD model as a baseline or any similar early design phase model?
Avide, you want to start, or you want me to take a swing
I
at
think
that?
you had a
it is the
slide
big
on this,
question, right?
actually, that
Yeah.
we had a lot of content on this that we had to take out to fit this webinar. But there's different ways to set the baseline. You could just assume a conventional building, but you could also take your SD design, early SD design, and set that as your baseline. That's entirely possible. As long as it's, the size hasn't changed significantly or something like that.
I want to add something to the 75% SD model as a baseline piece. That is a good way to do it, but what I would add to that is that sometimes in SD you're carrying some contingencies or allowances in material quantities that get reduced as the design progresses. So when you update the LCA, you want to make sure that you're not counting those contingencies that you're no longer carrying as reductions.
Yeah, I said in some of my responses to those questions that it needs to be functionally equivalent. Like, that's the whole point. So if there's something that's changed about the building that makes it not functionally equivalent, then that's sort of like the tipping point.
Yeah, it's like, and changes happen all the time in buildings,
Yeah.
right? So if you reduce 2 floors of your building and
exactly,
like that wouldn't count.
Yeah.
And the last thing I would add to that commentary is that there are standards under development now through groups like CLF and SC 2050 for benchmarking, and I could certainly imagine in the future something more like Title 24, where our baseline is more based on data of buildings rather than what we do now. But that is projecting into the future.
So that kind of really goes into the next question, which is like, it seems like there's sufficient concern and confusion about setting the baseline. And it would be ideal, like if we could provide a consistent measuring stick for all projects, like some sort of report or documentation, which seems like it's going to come. I guess one more question about a baseline. For the baseline GWP, is industry average the newest industry average or dealer's choice? Like, could you use NRMCA from 2020, or would you have to use it from like 2022?
I think best practice is to use the latest information that we have and the most regionally applicable. So NRMCA also has national averages, but because it's such a locally procured material, you're not shipping your concrete across the country, that you should use the regional, and in this next iteration of NRMCA, even some cities or even hyper local baselines will be provided.
And just, okay, thanks. And then just to clarify, are you basically designing 2 buildings? You're designing your baseline and then you're designing the actual building that you will be doing?
Yes, so 2 models, the baseline building model, which shouldn't really change much. That's a kind of a one-time thing. And then your proposed design model, which will keep changing throughout design.
So it's not really, it's two separate models, but not really two different designs.
Yes.
Yeah. And then another question is the 50,000 or 100,000 square foot threshold considered for one single building or for the whole project? So like if one project has like 4 different buildings, and collectively they accumulate 100,000 square feet, but each individual building is not, would it have to comply with CALGreen?
This is a tricky one.
I think we have Anish and Amy on as well. I think this was a question that we got last time, and I think there probably will be some supportive guidance in some of the supplementary materials, but Avide, if you have the answer, go for it, but maybe Anish and Amy might also be able to chime in.
It might be best to wait and construct our answer on this one, just to make sure that we're giving the right answer to everybody. But my hunch is it goes by permit, what's being permitted.
Yes, Abide, that's correct. It would be what the permit documents are. So if you're submitting that permit for all 4 projects as a single IFC set for to the permit officials, then that would be what is meeting or not meeting that threshold. But if it's like a phased project and you're submitting these permits like one at a time for each of the smaller buildings, it likely wouldn't be tallied up to that 100,000 square feet.
Thank you. So I'm going to quickly, so this is a kind of 2-part question. Who determines which pathway to take for a new building? Like who is determining whether to do whole building life cycle assessment or reuse or the prescriptive path? And then the second part of that question is whose responsibility is it to show actual constructed products match calculated reductions in design?
Avide, I think we talked about this on our previous call.
So it should be, it's the design, the team decides which pathway to take. So you're essentially deciding, do we want to go a prescriptive path to show GWP compliance, or do we want to go a performance path and actually do a whole building LCA? Similar to prescriptive versus performance and energy modeling, there's pros and cons to each pathway, which is why CALGreen provides both pathways. So you can decide. Sometimes the whole building LCA may be a more appropriate pathway, because even though it may require more work, it gives more flexibility, right? So there may be certain products you just can't meet the GWP threshold on for the prescriptive approach. In that case, you would choose to do the whole building LCA approach. And then who's the second part? Go ahead. Yeah.
The second part of the question was about sort of verification during construction, and there is no verification built into the policy, and that's where we really want to reinforce what Avide was saying earlier, that it needs to be documented and measurable, which it needs to be in your specifications. You can't just be picking limits out of thin air. It should be coordinated, particularly with the contractor due to cost and schedule impacts.
Yeah. Rochelle, I do want to make sure we answer Kyle's question, since it has a bunch of upvotes for the concrete supplier on the project. So he's asking if I don't have a concrete supplier on my project when I'm designing the building from a liability risk perspective, if there's no industry standard for how to establish a baseline building, what do I tell my client when my best practice LCA cannot be reduced 10% below the baseline without significant changes to the design when the contractor is selected? So this is a really great question. And I think, my personal approach as an architect to this would be to not rely on reductions from a material where we're not sure we can actually get the reductions. Once we have a contractor on board, that would be the first thing. So even though concrete may be the easiest thing, the lowest hanging fruit, if you really have that much uncertainty with it, that may not be advisable. The other thing, obviously it's good to make sure that whatever you're targeting for reduction is going to be constructed and it's going to be buildable, right? But keep in mind that CALGreen compliance only goes till permitting. So technically after that, I hate to say this, but after that, there's like Luke mentioned, no one's actually checking. Ideally, you're following through and making sure that it gets constructed that way. And I believe CALGreen is going to develop some measures for construction as well moving forward. But for now, it's really a design decision and a 10% reduction by permitting.
And I think that question also points to your previous comment of really doing an analysis up front to avoid that, oh, I'm too late to, to realize the impact that I could have had. Yeah. And having that communication with the client early and often and transparently. And I know we're at time. Sarah, I don't know if I'm sure we can answer a few more questions, but if you have some things you want to.
Yeah, we can answer a couple more questions, but just super quick for those that are still on or about to hop off. If you've made it this far, AI California will submit you for credit, and you will receive a VNCD certificate via email in the coming days. This presentation, the PDF of the slides, options for rewatching the video for credit, as well for without credit. So just to watch the video, those options will also be made available on our website. But I'll pass it back over to the panelists to see if we can squeeze in another question or two for those that are still on.
I actually wanted to try to cover a question that came up about using Tally specifically. So with Tally, you really only have industry EPDs. So the question is, how would the calculations take into account product-specific EPDs if that's how you're going to make your reductions? I don't think there's a really great answer for that necessarily, but
my go-to Tally Power user is Laura. So, do you have any thoughts on that, Laura? Not to put you on the spot.
So Tally has some industry average numbers. It also has some product specific EPDs for some products in there. So it's kind of a mixed bag.
but for like concrete, for instance, so like for concrete, if you have an industry EPD and you want to use a product EPD.
Tally allows you to input custom concrete mixes. So you can enter the mix proportions that match the mix you're actually going to use on the project. And then it will pull from Tally's background data. So Tally has its own background data that it uses for all of the ingredients in a concrete mix. So you can compare the mix proportions of your actual project mix design to the NRMCA baseline mix proportions. So it will let you do that.
But for something like steel, you're kind of in trouble though.
I have
really use a different steel one.
Yeah, I have a thought on that. This is something we've done on multiple projects is sometimes we end up post-processing the Tally LCA. So we can export it out to Excel and actually plug in if we have a very specific EPD we want to use for something that is important, will make a big difference in the whole building LCA, then we will post-process it. It's just a lot of it's just Excel work. It's nothing too fancy.
And I think this conversation is a great advertisement for joining one of these user working groups. Yeah.
I had also seen a lot of questions that are related to basically who's responsible for the information that's being provided. So is it like structural engineers or architects? And then also there was the part of it that somebody asked, I think Avade, that you mentioned earlier about like, how do you know what's going to be used later on in the project? So how do you determine that like the products you've actually used are valid or meet what you assumed? But somebody asked, well, if you're wrong and it's not the case, what would you do? Like, is it like who's liable for like making sure that that's right? Like, does the contractor at the end have to stamp something that says or sign something that says like, I can show that this met like the requirement or like the EPD provided at the end met like the kind of assumption that was put on the sheet that was submitted for permit, or is there another way that's kind of verified later on? It might be something I think we maybe have to clarify some of that in general, like in a future thing, but
Well, as far as CALGreen is concerned, currently, the way the language is written currently, there is no contractor verification required as of yet.
So it's up to the design team to ensure that like it's met what's been put in. Okay.
I think
Yes.
I just want to add to that because I think there was a couple questions about liability and like
Yeah.
legal risk associated with preparing the LCA. So I was wondering if they were just asking if there's any legal risk associated with preparing the LCA. Like, I mean, I don't think this will happen, but you know, if you submit it during permitting and it like stalls your project because the LCA is not compliant, I would assume that you would just have comments just like any other regular plan check process. But anyways, could you speak to that aspect of it?
I mean, I don't see a big legal risk simply because currently CALGreen is not requiring construction verification. Now, if and when construction verification is required, I can see how that might be a problem that we have to work through and resolve. But for now, since it's really essentially design based, you see, CALGreen is just trying to take the first step in getting everybody used to doing the whole building LCA, getting everybody used to the terminology. So this is, think of it as the training wheels for now. This is just the design LCA. But it's a good question because moving forward, if we do expand to contractor and construction verification, then it could have some liability issues, which we'll have to work through.
Well, in Marin too, so the Marin County Code is kind of like this a little bit, where you have to sort of show like what EPDs you're using for concrete you use in Marin County. And I think the contractor has to sign something that says that they got concrete that met like the requirements that were in the code. So it's not like that. I just wanted to clarify for people who are familiar with that. So.
And I was just having a call with some colleagues in the UK this morning, and they're saying more of the onus put on contractors as well, and seeing some either owners or municipalities attributing some level of like cost of carbon for projects that don't meet a certain performance threshold. So there's precedent and different things are happening in different places, but I think, yeah, these are all great discussions to be having. And maybe, I think there's probably a ton of questions. We will do our best to answer those after and follow up with more resources. But for now, do we think we close it here? And or are there any burning questions, Rochelle and John, that you think should be answered on the spot here?
Also, I do want to say that we have been putting together a slideshow of case studies of buildings in California that are already meeting, for example, the whole building LCA approach and reductions. Just as a resource to look through, get some inspiration. Maybe if you're unclear, you have a project similar, you can reach out to that team. So we'll be sharing that as well.
Yeah, lots of great resources, and maybe a quick plug if anyone's interested in getting engaged in volunteering some time with these wonderful people here. It's a very nice group, and reach out, and we could always use more help.
Oh, one more thing. Somebody asked a question about the transportation emissions, where I think I said in the mid slide that transportation doesn't add up to much because of the EPD, the individual product EPD. And Luke, you mentioned that transportation is there's some assumptions that are taken into place, taken into account by the LCA software. So the clarification is that there's transportation for A1 to A3, which is the transportation of, for example, the extracted materials to the manufacturing plant. That's captured in the EPD. And then there's transportation for transportation of the actual product to your building and so forth. That's captured in the LCA software. So it's broken out into two phases essentially. Luke, do you want to add to that?
No, I think that's, and that's summarized in that kind of colorful image. Wonderful. Well, I want to thank everyone who we have a pretty big panel of folks here, and a lot of people have spent a ton of time on this. So thank you all, and thank you everyone for joining. And I'll hand it off to Sarah for her thank yous or whatever we need to do to close here, but this has been great.
Yeah, no problem. Thanks again to all the panelists for all your work in putting this program together and taking the time today to share your knowledge and what you've done for this topic. And thank you guys, everyone, all the audience members for joining us today. And we will see you at the next CALGreen Embodied Carbon Series program focused on environmental product declarations. So thank you guys so much, and we'll see you at our next webinar. Have a great one.